All right, this is Mr. Werrick, and I'm going to go through these notes with you here today. This is going to be 3.5, defining congruence and similarity through transformation. So when we're looking at this one, it's how can you tell two shapes are congruent, okay? We talked about this before, but there's the shortcuts for the triangles that are like side, angle, side, 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 hypotenuse, leg, all of those. Angle, angle, side, I think is the other one. We could prove that, but basically two shapes are congruent if all of their angles match up and all of the sides are exactly the same. So if we're looking at these two, they should be congruent. If you're looking at these two, they're not congruent, but they should probably be similar. Okay, or like this one out here is not going to be congruent to that first one because it doesn't match up. The angles don't match up, the sides don't match up. There's just something different about it. Okay, so then when we look at the next slide, it says which blobs are congruent and how can you tell? So this was supposed to be kind of an exercise that was similar to a card sort. If you make it to where you can overlay these, that's really the only way. There's no angles, there's no like straight line sides that you can make measurements of. So the way that you can tell these blobs are congruent is not just, well, I looked at it and it looked congruent. It's the fact that if we take F and rotate it just so and move it over here, we can map F onto E and we can say, yes, these two are going to be congruent here because if we match them up, all of their measurements are exactly the same. So this is what we need to look at, and this is something that you need to make sure you put in your notes, you memorize, you understand this for the upcoming exam. A rigid motion transformation is a sequence of translations, rotations, or reflection. When it's a rigid motion, it does not change the shape of it in any way. So the only transformation we've done that hasn't been a rigid motion was when we did dilations. So then number two figures are congruent if and only if a rigid motion transformation can map one figure so it coincides with the other. So they're going to be congruent, coming back to the blobs again, if we can make some rigid motion things. We can rotate it, we can reflect it, we can translate it, and it's going to put one of them directly on top of the other, and they're going to match up. So on similarity, how can we tell if two shapes are similar as opposed to congruent? We have the same kind of ratio of sides there, and we have all of the angles being congruent. So no matter how we change the size of that shape, those angles stay the same, but then we have sides that are in a ratio to one another. If it's a triangle, all it's going to take is, if all the angles are the same, it's enough to prove that it's similar. When it gets into other shapes, a square and a rectangle both have all their angles as right angles, and they are not similar in that geometric sense. So it has to be pretty specific. The transformation that we have done that would create similar shapes would be dilation. We shrink it down, we make it bigger, but we don't change the angles on that one. Okay, so the similar transformation is a sequence of translations, rotations, reflections, and or dilations. So we have to have that dilation in there. We have to change the size. And two figures are similar if and only if a similarity transformation can map one figure so it coincides with the other. Again, we can tell that they're similar if we can change the size and then overlay them to where they're going to match up. So today's assignment is going to be, it's going to come from College Board. It's going to be on Schoology, and you'll need to make sure that you kind of measure the angles, kind of measure the sides, and be able to tell, are these shapes congruent or not, and say, yes, they're congruent. I measured the sides, the angles match up, whatever. And then if they are congruent, you need to make sure you stay the transformations that are going to map one of them to the other one. Is this going to take a rotation, a reflection, some translation? What's it going to take to put these where they need to go? Okay, so that's what you need to take care of today while I'm gone. And have a good rest of your day.